You've heard of real numbers. Would you have ever imagined there's something called an imaginary number? Imagine that. We need imaginary numbers to represent the result of taking the square root of a negative number. So it has been defined that the square root of -1 is not a real number because we can't in the real world take the square root of -1. So it's an imaginary number. It's defined as I. This allows us to simplify all square roots. For example, square root of -64, we would normally say, well, we can't do that. It doesn't exist, but it does. Square root of 64 is 8. Because of the negative inside of the square root, we will just tag it as an imaginary 8, 8i. And square root of -21, we'll do something similar. Square root of 121 is 11. We will tag it with an imaginary I, 11i. So then think about this. If the square root of 24, since it is not a perfect square, has to be simplified, would be simplified to root 4 times root 6, or just straight to 2 root 6, then the square root of -24 would be imaginary because of the negative. We would still simplify the square root of 24 the same way, but we would tag it as an imaginary. And the imaginary number will go behind the integer and in front of the irrational number, which is the radical. Pause the video and try these. We have a real number already of 3. It's multiplied by the square root of -100, which is 10i. And then 3 times 10i is 30i. Next one, we have a 2. We can simplify root 12, but root -4 is imaginary, or 2i. And finally, 2 times 2i is 4i root 3. Last one. We have a negative that creates the imaginary, and then the numerator and denominator are both perfect squares. We just take the square root and tag it as an imaginary number. Complex numbers include all numbers. All numbers are complex numbers. Whole numbers, integers, rational, irrational, real numbers are all complex numbers. A complex number can be written as a combination of a real number and a complex number, and looks like this. We've got a real number and an imaginary number. The real number comes first, the imaginary number comes second, and that is a complex number in standard form. These are all complex numbers. 3. 3 is also a real number. It's a counting number or natural number, a whole number, an integer, a rational number. It is not irrational because it's rational. -4 is a complex number. It's also a real number. It's an integer and rational as well. 5i is an imaginary number, which also makes it a complex number. Here's a true complex number because it includes both a real and an imaginary part, same as this example, a true complex number. Complex conjugates have the same real numbers and opposite imaginary numbers. For example, 3 plus 7i and 3 minus 7i are complex conjugates. The real number stays the same, it's only the imaginary number that changes sign. -2 minus 6i and -2 plus 6i are complex conjugates. 3i and negative 3i are complex conjugates. We'll use complex conjugates more in the next lesson. And here's a complex equation. It means that the two complex numbers are equal. If that's true, the real number parts must be equal and the imaginary number parts must be equal. In other words, 3x must be equal to 12 and negative 8i must be equal to 4yi. And then we solve both equations for x and y. X would equal 4 after we divide by 3. Y would equal negative 2 after we divide both sides by 4i. We are going to study more about complex equations, quite a bit more, but it's really interesting to note that fractals, complex numbers, are involved in creating fractals, which are beautiful designs shown on the screen and make gorgeous desktops. So if you're interested, go ahead and research fractals and see what you come up with.